Hi, I'm Tom Dean here. I'm field engineer with Point. I'm here with Flynn.
Hi there.
Hey, and today we want to talk about some multi-cluster magic. So, the evolution of clusters in Kubernetes has kind of paralleled the evolution of Linux deployments, but much, much faster, right? So, first, we built
Like
clusters
everything.
the hard way, right? We did it by hand, complete meat based automation. And if you want to do that, there's the repos out there on GitHub, and you can torture yourself with those. But
What are you
next,
talking about, Tom? Everybody loves Kubatum. It's my favorite
oh,
thing ever.
that's the next thing, right? I'm talking about like, Kelsey Hightower's Kubernetes the hard
Oh,
way,
oh God. Yeah.
manually assembling it. Yeah, I did that with OpenStack before we did the automation. We taught,
Mhm.
learned how to do it. And yeah, it's hard. So next we
Look at that.
did get kubeadm, right? That's the meat-based automation approach where you run some things, do some things by hand. Some things are automated. You can add some automation around that if you want, but again, that's what you learn for CKA, right? But it's not exactly the best way to do it. And finally, recently we've gotten some great tools, nice decorative tools where you can just bundle it all into one big manifest or a set of manifests, and then just go ahead and deploy that with something like Cluster API. So now we're kind of at the point where we can treat Kubernetes clusters as disposable assets, kind of like what we do with pods and containers, and it opens up a lot of possibilities that in old school IT or in early Kubernetes cluster deployment we didn't really have easy solutions for. So we're going to take a look today at the Linkerd multi-cluster extension and see how these use cases can be achieved, and Flynn's going to show us. And with that, here's Flynn.
Woo-hoo.
Woo!
Yeah, putting this together was kind of interesting actually, because I feel like we've talked about a bunch of these things before, but we haven't really gone through. And here's a practical way you can use them.
Yep.
So this is pretty much all about, here's a practical way you can use some of this stuff. Here's some of the effects, some of the things that start happening when you do have clusters that you can treat as disposable, and you can spin them up and you can spin them down. You can all this stuff, do all that stuff.
Yep. Yeah.
Um,
People have been doing things like namespace jails and other things. And if you think of virtualization on Linux, it was the same way, right? We did jails,
yeah,
change root jails. And then finally it gets to the point where
VM
you're like,
jails.
yeah, and that works for certain things. But, at some point you're going to really want where, hey, it's almost like going back to the old day of putting an app on a server, or you put an app on a cluster, but you can just destroy that, recreate it, and move it around. So everybody's into FinOps now and worrying about getting the lowest cost out of things. So you can move these things when you get great deals on compute. You just treat them as assets that you can create and destroy and modify as needed. Well, you don't really modify them, right? Generally,
No,
they're
the point is you
immutable.
don't modify them.
Yep, it's immutable. You don't care. It's a
Yep.
tool.
And with that in mind, I think we actually talk about a little of this. But first, a word from our sponsors. Hey, we have a book out. I wrote it with another guy, Jason Morgan. We hope it's good. Get it, check it out. Let us know what you think. The agenda for today, we've already kind of started the quick discussion of multi-cluster, but we'll walk through a couple of things about the way Linkerd handles it specifically. And then we're going to get into a demo. This demo is interesting because it's the largest number of clusters I've ever tried running on my laptop before. So this will be kind of fun. What you need if you want to follow along, that's the source repo. It's the practical multi-cluster directory within the main Service Mesh Academy repo. I will be using Buoyant Enterprise for Linkerd 2.15.5. I'm not sure what that random O is doing on the slide. There is no 2.15.5 so sorry about that. I expect everything in here to also work with Edge 24.7.1 and maybe some of the 24.6s, but I haven't really tried it with that kind of stuff. This is a little bit interesting because this demo requires both Kind and K3D, and we'll talk about why in a bit. Okay. Tom was talking about cluster evolution sort of following along with the evolution of Linux distros, that sort of idea. I wanted to talk about also that, in the beginning, when we started off looking at once we had the idea of clusters at all, and we were doing this cloud native thing, we started life in this single cluster world where you had an application, it was a bunch of microservices, they all ran in a cluster, and if anything happened to your cluster, that was very, very bad. This was also the world where people tended to think a lot about things like, oh, let me make sure the nodes in my cluster are happy, or oh, I have to go and mess with this node, or whatever. The whole node-based operation things, in my mind, goes back to this world. I personally tend to believe that if I have a node that needs any work, the correct way to deal with it is to throw that node away and get a new one, because I've never liked thinking of clusters as things that you have to babysit and take care of, right? After the single cluster world, we kind of got into this original old multi-cluster world where you would have two clusters, each of which had a copy of the application. And we're going to kind of show some of this, but the point here is that there's a lot of things that people did in this world sort of about failover, where you'd have it running in one cluster, you'd have another cluster that was idle, then you could switch traffic to your idle cluster, and then people started going, oh, hey, maybe we can run both of them at the same time and then cross load balance if we need to. And things started getting a little bit more complex. And eventually we landed in a world that looks kind of like this, which is the multi-cluster world that we tend to be thinking of, where instead of multiple clusters, each of which is running a copy of your application, you have an application that's spread across multiple clusters, however many clusters you need in whatever way you want to arrange them. This is the world we're talking about. I've called this cooperative multi-cluster before. The thing that's really cool about this model is it's actually fairly simple to reason about things, where you can just go, oh, this cluster belongs to this development team, or this cluster is for this chunk of data center, or whatever, right? There's a lot of different ways you can arrange these, but you have the options to go through and construct it in a way that makes sense for your application and your organization, instead of trying to make your organization fit the cluster boundaries. You also have some remarkably strong isolation between these different clusters, because, hey, they're clusters. It's very, very hard for a team working in one cluster to mess up a team working in another cluster, for example. And that can be really cool. And like we said, you also get to tailor the clusters. So, for example, if you have a microservice that doesn't work on Kubernetes 1.29, okay, just run it in a Kube 1.28 cluster. It's fine, you know. The downsides of the cooperative multi-cluster model, it can be more confusing. It does not necessarily have to be more confusing, but if you set it up badly, it will be more confusing. It also has some very, very deeply fascinating implications for networking. Depending on how exactly you do it, you might have to do extra work to do special network connectivity between your clusters, which might be easy or might not be easy. And pretty much whatever you're doing, there's really no way you're going to be managing microservice routing by hand. You pretty much have to use a service mesh for it. Fortunately, we know a good service mesh for this. And the other thing that's nice about it is that since we are using a mesh, then this whole cooperative multi-cluster thing ends up really being in a great position to take advantage of all of that stuff, where the mesh can just seamlessly provide you with security and reliability and observability and all this cool stuff, which is nice, even though it's happening across clusters. Now, there are two different ways that Linkerd can do multi-cluster. In 2.13, I believe it was, we introduced gateway-based multi-cluster, where if workload 1 in the cluster on the left wants to talk to workload 2 in the cluster on the right, it will actually do so by workload 1 will send its traffic to a Linkerd gateway. And, let me take this opportunity to apologize for the fact that we call it a gateway, because, oh dear God, has that become a massively, massively overloaded term. Sorry. Anyway, workload 1 will send its traffic to a Linkerd gateway in workload 2, and then the gateway will send the traffic on to, a Linkerd gateway in cluster 2, and then that gateway will send the traffic on to workload 2. Really simple. Works out really well, especially if you don't have seamless networking and things like that. We do get two interesting caveats with this approach. The first one is, yes, you are talking about some added latency here, because workload 1 has to send the traffic to the gateway, and then the gateway has to send the traffic on to workload 2. The gateway, for the record, is actually a Linkerd proxy. And that means that it's not much latency, but, it's non-zero. Laws of physics and all that. Caveat number 2 is that as far as workload 2 is concerned, it is not getting a request from workload 1. It is getting a request from the gateway, which means that the identity of workload 1 kind of gets lost in gateway-based multi-cluster. This can be a significant sort of downside. So for both of those reasons, in Linkerd 2.14, we introduced pod-to-pod multi-cluster that just looks like this. Pod-to-pod multi-cluster is really, really cool. Identities get preserved everywhere. All of the existing MTLS stuff just works. Everything you know and love about Linkerd policy just works. Everything you know and love about Linkerd routing just works. It's really cool. And the latency is lower. The downside of pod-to-pod multi-cluster is that you must have the ability to do a direct IP connection from one pod in one cluster to another pod in another cluster. This implies certain things, like your clusters have to be using different cluster CIDR ranges, or very, very crazy things happen, and you have to have IP routing set up, and lots of fun stuff like that. And the end result is that depending on who your cluster provider is, this might be easy, like it is with Kind and K3D, or it might be literally impossible. There are some cloud providers that simply cannot do this ever. The upside is that for those people, you can just use gateway-based multi-cluster, and it works fine. You can use both of them in the same cluster at the same time. It works. Some things to be aware of. This really should be titled any sort of multi-cluster, things to be aware of. Pod-to-pod is only available in 2.14 and later, like I said. We're going to see examples of some of this stuff, but there's a Linkerd multi-cluster link resource that gets used in both of them to connect clusters together. You still have to, it's actually the labeling services. I'm terribly sorry, I lied. You put a label on a service in one cluster to allow it to be exported into other clusters. And big caveat, Linkerd is doing MTLS between clusters, which means that all of your clusters in a group have to share the same trust anchor. Even that is slightly not true, but it's the simplest way to look at it. There has to be a trust relationship between them. All right. What do you think I missed before we go into the demo, Tom?
I think that's good. I will say, just learned last week that we do have like a process too. So if you have an existing cluster and you want to start linking it to other clusters, you can build a bundle and you can import trust routes and all that. So you don't have to throw out what you've got if you don't want to. It would be an opportunity if you want to, do a fresh start and rotate in some nice new trust routes, but you can do a bundle as well.
It's, like I said, it's technically not correct to say things like you have to have the same trust anchor, but it is very much the simplest way to do it.
Yeah, it takes a lot of complication out of it.
At minimum, the requirement is really that every cluster's trust bundle has to contain the trust anchor for every other cluster.
Yep.
Is the simplest way to look at it if you want to get really technical.
It's like SSH keys, right?
Yeah, it's a surprisingly good analogy. It has all the downsides too.
Yeah, managing a big distributed collection of keys.
Yeah, it's pretty terrible. Okay. Can you read that, Tom, or is that too small?
Maybe bump it up just a bit.
All right.
I have my glasses on, but let's look out for everybody who's not wearing theirs.
You're going to see some weird things with the mouse for a moment while I go and click around with stuff.
There you go.
Let's do that. And yeah, don't try this at home, kids. Okay. All right. So just, ignore this stuff up top because you're about to see it in a second anyway. We often talk about multi-cluster for performance or availability or, funky things like that. But really today is more about using it as a tool for managing your development process, for making your clusters fit your organization, things like that. We're going to talk about using an entire cluster for progressive delivery instead of just a given workload. We're going to talk about really kind of all sorts of crazy things. And we're going to be doing kind and K3D at the same time, where we're kind of letting kind and K3D stand in for different cluster providers. We're going to use Buoyant Enterprise Linkerd 2.15.5 is what I'm using. Tom mentioned the cluster API. I did not use the cluster API going through and setting this up, but I did realize that, oh my God, I was going to be creating and destroying a lot of clusters doing this. So I ended up writing a thing called local cluster that does not do anything you can't do by hand, but does make it simpler, at least for me, to go through and say, just crank me up a new cluster and get Linkerd running on it and get Linkerd multi-cluster running and fix the IP routes and do everything that I need. And yeah, that made life easier. Caveats. The big one, if you're using a Mac and you're using Docker Desktop, this is not going to work. I'm just going to start putting that in for basically everything that I'm doing, because OrbStack is so much nicer and it lets me treat things like kind clusters on my laptop in much the same way that I would treat them if they were in a cloud provider, where I can just go and grab the service's external IP address for a load balancer service and it just works. It's really nice. Also, in this particular demo, we are only showing IPv4. The reason for that is that IPv6 in Buoyant Enterprise for Linkerd will be coming in 2.16, but it's not yet in 2.15. So we're doing all this with just IPv4. The last Service Mesh Academy, of course, was IPv6. If you are using the Edge version of Linkerd, I expect everything in here to work just fine with v6. But I'm going to be modifying that later once 2.16 comes out. Okay, finally, and this is a big one. If you're really serious about doing multi-cluster stuff and you're serious about multi-cluster for DR and that sort of thing, you are rapidly going to get into the world where you need to be worrying about proper global high availability ingress. And since this is Service Mesh Academy and not Ingress Academy, we are going to fake that. What I have is one specific cluster whose name is CDN that mimics a CDN. And we're going to talk a little bit about sorts of things that I'm doing with that. But just realize, if you're thinking, oh my God, that CDN cluster is going to be a single point of failure, you are absolutely right. And this is not the way you do it in the real world. That said, I really did not want to go and mess around with the kind of BGP madness and things like that I would have had to mess around with to do this in a really cool, globally available way. So yeah, we're going to hand wave past that one and move on. So let's get started. All right. As a starting point, I have several clusters that are already running and have already been set up, because I could either burn a lot of time setting them up, or I could let you see an enormous amount of text flying by the screen for 5 minutes. So I just set it up ahead of time. We have 3 kind clusters. The Faces cluster is the only one we're using at the moment. The Faces cluster has the Faces GUI or the Faces application running in it. I actually kind of lied on that one. I need to tweak that text. In an earlier version, I was running Faces with a load balancer service, but since you don't have to do that the way this is set up, I turned it off. So you can see there is no external IP here. This is not a load balancer service. We're going to be relying entirely on Linkerd multi-cluster for access. In the CDN cluster, I have that Faces GUI service from the Faces cluster mirrored into the CDN cluster. When you mirror things, they show up as a service whose name is the name of the service, and then a dash, and then the name of the cluster from which it is being mirrored. So this is the way that you can basically get the service to appear from one cluster in a second cluster without stomping on whatever service you had there in the first place. Now, the other thing that we're doing here that is really massively cheating in the CDN cluster is we are running Emissary as our kind of content delivery network wannabe. And we have Emissary set up simply to say anything that shows up to port 8080 is going to get handed off immediately to that Phases GUI Phases service. In other words, this is TCP routing, not HTTP routing. This is all happening at layer 4. Any connection, if it arrives on port 8080, it immediately gets shifted over to that mirrored service from the Phases cluster, at which point Linkerd should pick it up and hand it on off to the actual thing in the Phases cluster. And the reason that it's port 8080 is if we take a look at Emissary's service, it's actually using port 8080 as a target port, and this is the way you do TCP mapping with Emissary. Now, Emissary is not really the right tool for this job. There are other tools that would be ideal, or more accurately, I would prefer for there to be other tools that are better at this. It turns out that a lot of them are really, really difficult to get running and or require that you to build them yourself or both. So yeah, Emissary and Linkerd play really nicely together. So I ended up just falling back and doing it this way. Now, that being said, we have an IP address for that Emissary service. And if we go over to the browser, look, it works great. Up here in the browser, you can see that I'm talking to the same IP address that I just got for the CDN, and I have a working Phases application, despite the fact that I'm talking to a different cluster here. So all by itself, this is kind of interesting. But this is not really multi-cluster when you think about it, because really what's going on here is I'm mimicking having a CDN talking to the Phases application all running in one cluster. So let's go ahead and fix that. What we're going to do here is we're going to set up Linkerd's pod-to-pod multi-cluster to kind of use clusters the way we might have used namespaces before. We're basically going to pretend that our Smiley workload is complex enough that it has an entire team of people who are working on it. So we're going to give the Smiley development team their very own cluster and then link it in to the Phases cluster so that everything just works. This is the only time that I'm going to show what really goes into setting up a cluster and linking it together and all of that stuff. So let's get into that. Setting up a cluster for multi-cluster is one of those things that's not hard, but there are a lot of details to keep track of. So I did this thing called local cluster that goes through and reads this sort of a thing that basically tells us the name of the cluster and whether we want to do v4 or v6 or both. Do we want to use kind or K3D? And do we want this to be linked together with pod-to-pod multi-cluster and other things? We also have some stuff in here to go through and make sure that everybody gets a unique cluster CIDR range. If I run this local cluster command and I tell it to do, hey, make me one following that definition of Smiley that you just saw there, it's going to do a lot of things. First up, it deletes any kind cluster named Smiley. Then it creates one. It actually writes the kind config to do all the right things. Next thing we do is when kind creates a cluster, it shows up with a Kubernetes configuration context of kind-cluster name, which gets really irritating to type. So the next thing that happens here is we rename the context to not have the leading kind because it shortens everything. Kind also, actually K3D does this too. When you create it for the API server for that cluster, it actually does a port forward and then sets up your Kubernetes configuration to say that the API server is on some random port on localhost, which does not work very well at all for multi-cluster. So these two lines are local cluster editing your Kubernetes config to tell it where the API server really lives. Don't try this at home, kids. Since this is kind, we need to go ahead and install MetalLB to go through and do load balancers. This bit is figuring out how to configure MetalLB. This bit is in waiting for the nodes of the cluster to be ready. This bit is installing MetalLB, and this bit is finally configuring MetalLB with the configuration we generated a few steps ago. Not shown in the dry run is that we will then go and do a bunch of IP route add commands. So everybody cross your fingers. This is one of those things where it always takes long enough during the demo that I get a little worried whether or not it's going to work.
Yep.
Yeah.
Patience.
Yep. It's nice that kind kind of tells you what it's doing and things like that, right?
Yep.
So there's our cluster, there's renaming the context, there's updating the API server's address, and now we're waiting for the nodes to actually be ready. If you don't wait for the nodes to be ready, and I learned this the hard way, if you don't wait for the nodes to be ready, but you do install MetalLB gets really confused because it can't find any CIDR ranges, can't find any CIDRs because the nodes aren't ready, so they haven't filled out their CIDRs yet. Eventual consistence. It's a lovely, lovely thing, right? Now we're waiting for MetalLB to come on up and be running. And there we go. Now, the next thing that happens here is a ton of IP route add commands. I'll pick on, like, this one is a new one where what's happening there is that the faces cluster needs to be told, hey, it's okay for you to route to our newly created smiley cluster. Our newly created smiley cluster is using this 10.5.1.0/24 range for its service CIDRs. Sorry, it's pod CIDR. And its address is 192.168.155.11, which I happen to know because we can see it in the output up here. So we can see that this one got added. The way local cluster works is that it always reruns all the IP route add commands for all of the clusters in this group. So a bunch of them are already duplicates, but that's okay. And yes, there are more clusters in here than just faces and smiley, and we will come back. You'll see where we use those later. So now we need to get Linkerd going, which means we need certificates. So the first thing we do is we make certificates for the smiley cluster. I'm not going to go through these commands very much. They're basically they are taking advantage of the fact that we have already created a trust anchor and just going through and creating new certificates for our smiley cluster itself. These are the identity issuer certificates. There are many, many SMAs where we go through exactly what those step certificate create commands are doing, so we're not going to reproduce those here. Given an identity issuer, then we get to go through and install Linkerd. And again, this is Linkerd, this is multi-cluster Linkerd, right? So we have to do a couple of things. The first thing we're going to do is install Linkerd's CRDs. Then we're going to install Linkerd itself. We're explicitly turning off IPv6. We are explicitly setting the trust anchor. We're explicitly setting the identity issuer certificate. We are explicitly setting the identity issuer's private key. Those are the ones that we just created. As always, when you run Linkerd install, you then get a bunch of YAML that you apply with kubectl apply. And then at the end, we run Linkerd multi-cluster install because we need multi-cluster working. While that is running, I'm going to point out a thing. If you look up the documentation for Linkerd multi-cluster install, you will find that there's a -- gateways switch where you can set gateway true or gateway false. At this point, my personal recommendation is that you never set gateway to be false, because if you leave it set true, you end up with a cluster that can do both gateway-based multi-cluster and pod-to-pod multi-cluster, and they both work just fine.
I was wondering about that because I was trying to do some gateways with mine and I wasn't getting it working. Good catch.
Yeah, so this is my recommendation. Never give the gateways command, never give the gateways flag to either Linkerd multi-cluster or to Linkerd multicluster install or to Linkerd multicluster link. Just leave it off, and then you get something that can do both if your network supports it.
Nice.
What's happening here is that we're running the Linkerd multicluster install, and that had to wait for the rest of the control plane to come back up. So I'm actually going to cheat a moment. Let's do multi-cluster check. And you can see that it did get installed. I'm not actually going to bother running the whole Linkerd check right now. So the last thing that was going on here was let's link up Smiley with the rest of its group. This is going to run a bunch of Linkerd multi-cluster link commands. And once again, just kind of ignore color and color B and all that and just let it happen. Mm-hmm. You can see here that we're actually doing these links bidirectionally. We don't really need them to be bidirectional, but it was, yeah, why not? It's not a downside for what I'm doing here. And as mentioned before, there is no -- gateways flag here. So we'll run multi-cluster check again, and now it comes back and says, oh yeah, our links are valid, remote cluster access is valid, they share trust anchors, all this good stuff. I'm not going to worry about that right now, but it might be kind of fun later. Interesting. Okay. You know you're doing a software demo when something happens that has never happened before.
First time ever. It's a grand preview.
Yeah, it'll be fun. Okay, so all of that was basically how we create a cluster, get Linkerd installed in it, get Linkerd multicluster installed in it, get IP routing set up, link it to all of our other clusters, and now we can finally go through and install faces into our cluster so that we have something to talk to in the Smiley cluster. We're going to create the faces namespace. We're going to mark the namespace as yes, please inject things with Linkerd, and then we're going to go through and install faces. The faces Helm chart is a little bit silly about this. It would be better if I added something to the chart to say, hey, I only want the Smiley workload, but I didn't do that yet. So what we're going to do is install the whole application and then immediately delete a bunch of deployments, which is silly, but whatever. Okay, now finally we get to mirror the Smiley service using pod-to-pod multi-cluster from the Smiley cluster into the faces cluster. If you look at the docs, you'll see that in some situations you'll do exported equals true. That's if you want to do gateway-based multi-cluster. For pod-to-pod multi-cluster, you do exported equals remote discovery. Another subtle but very, very important difference. All right, so if we do that, you see this smiley thing? That's the Smiley service being mirrored from the Smiley cluster. And at this point, we should be able to use an HTTP route in the faces. We'll put this in the faces cluster to say, okay, any traffic to the Smiley service in the faces workload should instead be directed to the Smiley service. And if we do that, we should start seeing hard-eyed smileys. Just to prove that we're not really cheating on this one, I'm going to delete the deployment for Smiley in the faces cluster entirely. Okay. There are a few really fascinating things about what we just did that are not at all obvious when you watch it. The first one is we actually took a workload running in one cluster and migrated it to another cluster. Kind of doesn't look like it because we did this by installing it in the one and then routing over and then deleting, right? That's a migration. That is, in fact, a really good way to do migration of stateless apps. And it's a great way of doing it if you want to treat the clusters, as Tom was mentioning, as disposable, ephemeral things. We also did this without changing the workload in the slightest. The Smiley workload does not care what cluster it's running in. So the fact that we have the mesh mediating communications means that we don't have to do anything at all to make the Faces application work across cluster boundaries. We also did it in a way that permits progressive delivery, although we didn't show that. So let's go ahead and show that. In my color workload, in my color pod that y'all have seen existing beforehand, I have the color workload, and that's the only thing running in it. So I'm going to go ahead and mirror the color service over to Faces. And if I look back in the Faces, this is very hard to remember when I mean to say color and workload and things like that. If we go and look in the Faces namespace in the Faces cluster, and we look at its services, we will now see that there is a color service, which is the mirrored service from the color cluster. Next time I do this, I'm giving these clusters different names. I should also have pointed out earlier that the color workload in my color cluster should be returning green, not blue. In this case, we're not just going to switch the whole thing whole hog. We're going to switch it in a progressive way. Hang on a moment. Talking about all these clusters, I must be allergic to it. Okay. In the Faces namespace, when we see traffic going to the color service, then 90% of it will go to the color service, but 10% of it will go to the color service. So when I apply that, you can now see that we're seeing some green in there. This is stochastic. We're not always going to see exactly 1.6 green cells in here, but we can go through and edit that route. And y'all have kind of seen this part of the demo before in various ways. Actually, let's do 75, 25. Why not? Or at least those of you who have watched earlier renditions of Zivers Mesh Academy will have seen some of this. This is exactly the same way that we have always done progressive delivery. The difference is that we're doing it across cluster boundaries right now. And it even works to do this business where we say a 0-100 split so that everything is green. Kind of cool. So once again, I can just go ahead and delete the color workload from Faces and everything still works fine. But I also have a pre-created color B workload or cluster, which has the color workload returning the original blue. And so now this is going to be kind of fascinating because color B was the one that showed an error earlier. So let's see what happens here. If I look in color B, I've got a color workload over there. Let's mirror it into the Faces workload. We now have a color service. That's the original one in the Faces cluster. We have color, which is mirrored from the color cluster. And we have color B, which is mirrored from color B. And let's try this, shall we? This is exactly this. It's pretty much the same thing. It's important to note this is the same name as we just used a minute ago. So I am overwriting my HTTP route to change its backends. Now we're going to do 90% to color and 10% to color B. Everybody cross your fingers. Hey, it looks like it's working. Okay, good. I was kind of worried about that. Let's just jump straight to a 50-50 split here. This is basically exactly the same thing as we did before. I'm not going to lie, when I was going through and practicing this at one point, I edited the wrong weight and got really, really confused why I suddenly was ending up with more green instead of more blue. So, learn from my mistake. Don't do that. And now we're back to a world where we have nice blue backgrounds, so we have heart-eyed smileys, and There is no color workload running in faces anymore, and there's no smiley workload running in faces. I'm going to demonstrate that by control Zing out because I can't remember if I put it in the demo script or not, and I really want to show this. All we have in there is we've got the face workload and the GUI workload, and that's it.
This is a great way that you could take and move workloads out of a monolithic cluster and into their own clusters as well.
Which is pretty much what we're doing, right? The faces cluster was our monolithic cluster, and we're just moving it out.
Yep.
Okay. Once again, there are some very, very fascinating things going on because we just did progressive delivery where we have the two versions of the workload that we're canarying between are in two different clusters, but we were using a route on the third cluster to make this work. This is obviously a great tool for letting development teams work independently, because if if the team working on color B is going through and doing all manner of crazy stuff, they cannot affect the team that's working on color or the team working on faces or any of that stuff. But another really interesting thing, which we hinted at earlier, is that you have a lot of control over what happens with these clusters. So the only real requirements for Linkerd multi-cluster are, one, you have to have some kind of network connectivity. We're using pod to pod. That requires more network connectivity in general, but the sort of mirroring stuff, this works with gateway as well, gateway-based multi-cluster. So you have to have some kind of network connectivity, and you have to be using versions of the Linkerd data plane that have a compatible wire protocol. That sounds like a bigger deal than it is. I'm not sure the last time we changed the wire protocol the control plane, not the data plane. I'm not sure the last time we changed the wire protocol at a level that would affect this. So the end result there is that if you want to be running different versions of Kubernetes, fine. If you want to run different versions of Linkerd, fine. If you want to use different CNIs or different versions of the Gateway API or, whatever, it pretty much just works. I didn't put it on this list, but one of the ones that would have been actually kind of fun to play with was we could also do this, for example, where some of the clusters are using the Bell operator and some of them aren't.
Yep.
Fine. No big deal. It's great. It's just, it gets really interesting because the strict requirement is so small.
Yeah, you could have different cloud providers that have different capabilities as well. You think about that.
We
didn't even mention that, right? But you're like, I got to run this one piece here because of a vendor requirement or whatever, right?
Yeah.
You're locked into something.
We're going to talk about that. And also remember that if you want to do things like, a different version of Kubernetes, you can actually do an A/B deployment with this, where you have the A side is your color workload running on Kubernetes 1.25, and the B side is the color workload running on 1.29, and that is fine.
No more upgrading. You just create a new cluster at the version you want, and that's it. And when you're done with the old one, you just throw it away.
I really missed an opportunity. I should have done that.
Yeah.
Okay. Also, I want to point out some notes about routing here. If we look closely under the hood and we kind of zoom in, the browser is making an HTTP request. Specifically, the browser starts off loading the GUI from the faces GUI workload, but then every time after that, for each cell, the browser makes a request to, the face prefix that's going to go through and eventually hit our emissary service in the CDN cluster. Because remember, my browser is talking to the CDN cluster. Emissary recognizes, this is a TCP connection coming in on this port, and so it funnels it over to the service in the CDN cluster that has been mirrored from the faces cluster, at which point Linkerd in the CDN cluster recognizes that it's a mirrored service and hands it off to the faces cluster via the Linkerd gateway, because this is what Linkerd does with mirrored services. The faces GUI in the faces cluster, this is a bit of an implementation detail. Actually, you know what? This is a wrong implementation detail. Sorry. The face workload in the faces cluster Oh, no, sorry. This is not wrong. See, this is where I'm getting myself confused. This is great. We're still at the level of emissary here. So the emissary request goes to the faces GUI mirrored service, which gets caught by the faces GUI in the faces cluster. It then turns around and makes a request to the face workload in the faces cluster. From the faces GUI workload to the face workload in the faces cluster, Linkerd is doing MTLS, but that is all within one cluster boundary, so everything is great. The face workload is then going to make requests to Smiley and Color. Those have HTTP routes in the faces cluster. Both of those are redirecting to mirrored services themselves, so both of those get picked up by Linkerd and handed off to another cluster. Because again, that's what mirrored services do. Now, this is a little bit interesting because there's a bit of an axiom in Gateway API that you only get one layer of routing. You can't do something where you have an HTTP route that points to another HTTP route and cascades on like that. So this raises a question of, all right, how are we able to do this? I'm going to put Tom on the spot, but I will give Tom the hint that the fact that emissary isn't actually using Gateway API has nothing to do with this. There's something else fundamentally happening here.
Emissary is meshed.
Emissary is meshed. That's not, yeah.
No, you're going to have to tell me.
This is one thing I kind of miss about when we were doing this only with Zoom. It was easier to ask the people in the audience about this stuff. The critical bit is that there's actually two separate requests that are happening here. We're not trying to do HTTP route to HTTP route because there's a workload in between. So you've got the browser, which goes to the CDN, the emissary in the CDN cluster, which goes to a Linkerd mirrored service, which goes to the face workload in the faces cluster, kind of eventually. And then the face workload is generating separate requests. So since those are separate requests, each of them gets a chance to do its own routing magic. This means that as long as you set things up like this, where you have workloads that are cascading different requests, as opposed to trying to just stack HTTP routes on top of each other, you can do arbitrarily complex things with the routing. You can make it work however works for your organization. There is a latency cost. Realistically, with Linkerd, the data plane is fast enough that often the latency cost is just not going to matter. Okay. Now let's get on to Tom's point a bit about multi-cloud instead of multi-cluster. Right at the moment, we've been using kind clusters. We've got faces and Smiley and Color B, but actually that is a lie because the CDN cluster is a K3D cluster. I also have faces DR and Smiley DR. Just ignore those clusters, pretend they don't exist, at least for the moment. So every request that is happening from the GUI first goes into the K3D CDN cluster and then gets vectored over to a kind cluster right now. This is all MTLS, and it is relying on no special networking whatsoever because I'm using gateway-based multi-cluster for that hop because I'm pretending that K3D and kind are two separate cloud providers. The only routing requirement going on there is that the pod that you're coming from has to be able to talk to a load balancer service in the pod that you're going to. That's it. That is the only requirement. So if I look up information on my CDN cluster, this is the IP address of its node. Here's the pod CIDR. Here's the service CIDR. I can then go and look at my mirrored service. I can see that it has a cluster IP that is in the service CIDR range. That makes sense. And I can see that it has endpoints, but the endpoint looks completely bizarre. And this endpoint has nothing whatsoever to do with any of these things, although it does look kind of like the node address for the CDN cluster. If I look up things for my faces cluster, it also doesn't look even vaguely related to anything like this. It's faces GUI Note, this is faces GUI in the faces cluster, not faces GUI faces in the CDN cluster. It also has a cluster IP that is in the service CIDR for the faces cluster. And it has an endpoint, which is in the pod CIDR for the faces cluster. This endpoint arguably looks totally insane, but it happens that that is the external IP address and port for the Linkerd gateway workload or service in the Linkerd multi-cluster namespace of our faces cluster. So what's going on here is that when the CDN cluster tries to talk to faces GUI faces, Linkerd picks that up, shuffles it over to the Linkerd gateway in the faces cluster, and then the Linkerd gateway routes it the rest of the way. Fun fact, the Linkerd gateway is itself a specially configured Linkerd proxy. Also note that this is a load balancer service, which means that the whole point of this external IP is that it is something that's globally routable, which means that you should be able to reach it from anywhere. And since Linkerd is doing MTLS over here, it doesn't matter what kind of network you use to reach that. Between faces and smiley, things are very different. If we look at the smiley service in there, okay, good. It still has a cluster IP that's in the service CIDR for the faces cluster, but it has no endpoints at all, unless we run the Linkerd diagnostics endpoints command to look it up and see what the Linkerd control plane thinks about it. And that will tell us that it has an endpoint of 10.5.1.15, port 8000. And if we look at the smiley cluster, 10.5.1.15 lives in the pod CIDR range for the smiley cluster. And in fact, we can go through and look at stuff like this, and we see that the endpoints over here in the smiley cluster are exactly the same endpoint that we saw with Linkerd diagnostics endpoints over in the faces cluster. This is pod-to-pod networking, where Linkerd assumes that it can just reach directly across the network, directly to a pod in the other cluster. This is why you get to skip the gateways, skip some latency, preserve all your identity and all that, but also why you have to go and mess with IP routing. Okay. Let's go straight into disaster recovery. If people have questions, then please feel free to put them into the workshop channel. Oh boy, there's a bunch of stuff in the workshop channel that I have not been paying much attention to.
Oh, it's okay. I think we got 2 open ones right now.
Okay.
There was a question about mesh expansion and how that relates to the gateways. And I think I kind of got it laid out there where, anything you add via mesh expansion is going to be treated like an endpoint behind a service, right? And
pretty much, yeah.
Yeah. And so then you're going to basically label that service and it will get exported based on how you label it.
You end up using the external workload CR for mesh expansion. So it's kind of different, but under the hood, it's a lot of the same things going on.
Okay.
Why is the mirrored smiley service showing up in the faces namespace and not in the smiley namespace? There is no smiley namespace in any of these clusters. There's only a faces namespace. That's deliberate because one of the things that we haven't really talked about very much is that multi-cluster kind of assumes equivalence of namespaces. So you really do, I'm going to say you pretty much need to keep the namespace names the same for this to all work out right. Now I'm going to have to go play with that a little bit and see whether or not crazy things happen. Play with that a little bit and see if there's a way to not have the namespaces be the same. I'm not sure about that. I'm not sure there is. I also kind of missed a little bit of what you were asking about, Tom, with Sam's question of multi-cluster via gateway, but you also need VMs. That's actually a simpler answer, really. That's that you'll end up using multi-cluster to reach workloads in your FAR cluster, then you'll have external workload resources for mesh expansion. But that is a case where that you can't do stacked routing thing comes into play. So you're going to need to have some intermediary workloads to make all of that work correctly.
So you would call a workload that's in Kubernetes, which would then go call the external workload.
Actually, you know what? I'm going to have to go and try that and play with it a little bit more because I might be wrong about that.
Cool.
Yeah, let's take that as an action item because I just realized while I was saying that I haven't. External workloads have services, kind of. So yeah, you might actually just be able to mirror one of their services directly. All right, I'm gonna have to go try that.
Cool. Thanks, Sam. That was a good
Yeah.
one.
Okay. Disaster recovery. This is kind of anticlimactic, really, because we've already shown kind of how you do it. But let's go ahead and dig into it because there is, there's some important stuff to pay attention to. You saw earlier in my list that I have a Faces DR cluster that is already running Faces. It's already been linked to the CDN cluster, but it has not had its Faces GUI service mirrored yet into the CDN clusters. Let's go ahead and do that now. You'll note that I'm using exported true, not exported remote discovery, because this is gateway-based multi-cluster. The CDN cluster is in no way special. It doesn't have IP routes to anything. It's just hanging out there, acting like a CDN. So we use gateway stuff there. If we do that, we now have Faces GUI, Faces DR, and I am now going to take advantage of something that Emissary does, where I'm going to add another TCP mapping. This one saying from port 8080 to Faces GUI, Faces DR. And if I apply that one, then Emissary just knows how to do a 50-50 split based on that. Remember that this is, oh, hey, that worked quicker than normal. Remember, this is TCP mapping, and the browser can kind of hold TCP connections open for a while. So in a lot of situations, I've ended up having to go reload my browser window and things like that to try to flush some of the connections and get it to make new connections. Yeah, like I said, the way we're pretending our CDN is CDNing is not ideal here. But in this case, it worked great. The DR cluster there is in fact set up to return the screaming face on a white background because it's only there for disasters. So disasters involve screaming or something like that. And this gets us into some interesting questions, right? So Emissary is trying to do a 50-50 split with our CDN. What happens if we just scale our original thing down to 0? As it happens, Emissary deals with that a lot more gracefully than I was afraid it would, but you still see some errors happening every so often. But after a few seconds, we basically just get screaming faces on white backgrounds, which I'm not going to lie, this was a surprise when I first ran this. Mm-hmm. I was expecting to see half of my cells just get the purple frowny face because it was still trying to do the routing. In the real world, if you were going to do this, you would really want to be doing this with active health checks and modifying your mappings and things like that. I'm going to go ahead and scale our original GUI back up. And now I think I do need to go reload this a few times. You start seeing it come back with our original one. Now I will get rid of the mapping for the DR. And I'm going to go ahead and reload a couple of times because I'm impatient. And now we've gotten rid of all of it, so we're just back to normal. But there's no magic here. If you're talking about DR, it's exactly the same as doing a migration, which we've been showing over and over and over again. There are obviously other kinds of failover here, right? This was pretty much doing active-active failover, where I had both clusters running and then something goes wrong in one, and so all the traffic gets taken up by the other, which is no big deal. You could do active-passive, where you've got one cluster that's up that's not taking any traffic, and then when something goes wrong with your first one, you swing it over. You could, in fact, wait for something to go wrong, and then spin up an entirely new cluster and start routing to it instead, which seems insane, but honestly, setting up this entire demo on my Macintosh only takes about 5 minutes. So, sure, why not? It's not really that long. Maybe that's the simple way to do it. I personally kind of tend to prefer that, active active I think makes more sense, but you have a lot of options. The point here is that once you have working multi-cluster, switching over to an entirely separate cluster is really easy and really fast. So you have a bunch of options. The other thing I was going to point out here, first off, I lied kind of. I already showed the smiley thing, but actually, wait. Sorry, I was going to talk about another thing first. I'm getting ahead of myself. Yeah, so the faces cluster and all of the other stuff like smiley and color B, those are kind clusters, but face DR is a K3D cluster. So we were also showing a multi-cloud failover here. Since there's nothing special about the networking that we're using for gateway-based multi-cluster, it doesn't matter. You can do multi-cloud all you want. So, if you want one of these to be in GKE and another one to be in AWS, or one of them it's EKS and one of them it's Azure, yeah, fine. It doesn't matter. All of those provide load balancers with globally routable IP addresses. You're good to go. To Tom's point, this also means that you can do things like, we're kind of stuck on GKE because we're using some GKE specific database or whatever, but you could move the rest of the workloads off GKE and it'll work just fine. Then as you figure out a way to port the database over or whatever, you can go and canary off of GKE. So lots and lots of options once you get this stuff working. Oh yeah, and the other one I was going to mention was this bit. Everything is MTLS, so you don't need VPNs either. You can just route traffic over the public internet, and it's not a big deal. All right. Then the bit that I started to get out of order on. The Faces DR cluster doesn't actually have the Smiley workload. The Smiley workload lives in yet another K3D cluster called Smiley DR. Faces DR and Smiley DR are doing pod-to-pod multi-cluster with themselves. So we're actually showing a multi-cloud, multi-cluster failover as we do this.
Mixed with gateways.
And unless you start looking under the hood, you don't even notice, which is pretty cool. All right. We talked earlier about how the CDN cluster is a single point of failure. I'm going to reemphasize that here because, not how you would do this in the real world, but it works well for this thing. Migration, that's pretty much what we've been showing forever here, right? We moved the Smiley workload from the Faces cluster over to the Smiley cluster. We progressively moved color from Faces to color and then progressively to color B. So we actually did two different steps there. Since the color workload is still running in the color cluster, we could just as easily swing that back if we wanted to. We did the active-active failover between Faces and Faces DR. But okay, fine. We did go ahead and bring that back. So let's just go ahead and demonstrate that we can do that and leave it swung over, right? Why not? So we put the mapping back for taking, sorry, brain cramp. That's re-adding the mapping that takes traffic to the Faces DR cluster at all. And you will notice that this time I didn't magically get that to happen. There we go. I had to reload the browser. Now I can delete the old mapping entirely. And once I reload a few times, then eventually I will get all screaming faces in a white background. And then I can delete all of my kind clusters entirely. And yeah, there you go. So there you go. We've just done a cross-cloud migration and all is well, or something like that. Yeah. There's just kind of not a lot more magic to that one. The upshot of all this really is that Once you have a really easy way to route across clusters, you also have a really easy way to migrate across clusters, which is a very, very important lesson from all of this stuff. That's kind of the point of the practical multi-cluster thing, is that, as Tom was mentioning, we have better tools than, or at least different tools than namespaces now. There's a bunch of stuff we can do where as soon as you get to do magic where you can treat clusters as disposable ephemeral things. You can spin them up, you can spin them down, you can just hand off whole clusters to development teams. Once you're able to do that, you have a lot of really, really interesting tools at your disposal, because the cluster boundaries take the place of the namespace boundaries. And since you have entire clusters to play with, you get to configure them exactly how you want. So there's lots and lots of interesting stuff here.
Yeah, multi-cluster really is, an instrument like a guitar or a chainsaw. It's, you can use it however your mind conceives, right? Within the constraints of the universe you live in, right? And so when I talk to customers about it, it's like, well, how do I tell them that this thing it's not cookie cutter, it's not whatever, it's whatever you want to make with it.
Yeah.
When you pair it with modern automation and cloud, and you can repatriate. That's the other thing we didn't talk about. A lot of folks are repatriating, one or more parts of their apps and bringing back in house. Or if you want to run part of your crown jewels on prem, you can use multi-cluster for that. It really removes the constraints and the boundaries.
I confess I find it a little amusing that you went straight from guitars to chainsaws there, but
They're
I
both
suppose I shouldn't be too surprised.
Dangerous and musical.
We have a little bit more time here, so I am going to do one more thing. Let's live dangerously and do a canary between a cluster on my laptop and a cluster that is actually really running in the cloud. In this case, a Civo cluster. So I have a Civo cluster, and it has Linkerd and it has Faces installed. And I reset the whole Civo cluster right before starting the demo, so I haven't tested it. So this will be a little bit more entertaining than normal. But we've got this thing running out there. You can see it's got a radically different sort of IP address there than what we have seen before. It's got Faces running. It's got Linkerd. It's got Linkerd multi-cluster. I did not link it to anything yet, so I'm going to link it now. I'm going to link this to the CDN cluster. Very important note, my laptop can talk to the Civo cluster, but the Civo cluster could not reach back over the global internet to my laptop. So this is a case where I can only do this link in one direction, which for our purposes is fine. It's just a thing to be aware of.
Well, that removes a constraint too, right? You don't have to have bidirectional links.
Yeah, I should probably have mentioned that a little bit more emphatically, right? When I set up the local cluster command and it was doing all the linking, it did the linking bidirectionally. You don't actually need to do that.
Yeah, you might have some vendor that you've got, a component, or they've run a Kubernetes cluster or a SaaS or whatever it is that you want to talk to, and you're not going to get that level. You're one-way relationship.
Yeah, which again,
this is perfect.
Fine. Yeah. So once that's done, we get to mirror the Faces GUI service from our Civo cluster into the CDN cluster. And here again, I definitely do not have pod-to-pod IP routing set up, so I'm using exported true to do gateway-based stuff. I can do that. I can make sure that everything is okay. Oh, good. Everything is okay in the Civo Faces cluster. If I run that again, run that multi-cluster check in the CDN cluster. This worked last time. I'm getting a little concerned.
Patience.
Yeah, really.
I call this the Route 39 problem. Back at our lake house, I'd always think I missed my turn on Route 39. I'm like, all right, just patience. And here it comes.
Remote cluster access credentials not valid. Oh, this could be a problem. Well, let's see what happens anyway, shall we? I have endpoints? I have an endpoint. Let's try it.
It's just a warning then.
Um, it's definitely an interesting warning for sure.
Yep.
Actually, you know what? Let's. Oh, I'm being an idiot. Liveness checks failed for faces. That's because I deleted the cluster faces.
Oh, there you go.
I left the link there.
Makes sense now.
Whew. All right. Now, the last thing we were doing before I went out was we were about to apply the TCP mapping. It's exactly the same thing as we did before, where port 8080 is going to go over to faces GUI SIBO faces. The mirrored service here. Apply that. And let's reload a couple of times. Yep, I saw a smiley face or a grinning face. I still left it as a white background, but the SIBO cluster will be returning grinning faces. All right, let's live dangerously and just delete the old mapping entirely, shall we? Instead of doing anything polite with progressive stuff. So there we go. That means that what we just did was migrated the Faces app from my laptop to a cloud provider. You might have noticed that it seemed remarkably like doing it between Kind and K3D. Which, again, kind of the point. You have a lot of things you can play with here where you can basically just mix and match whatever pieces you want for the most part.
Yep. A cluster is a cluster is a cluster.
Yeah. Feedback welcome. You can hit me up on the Slack channel. You can reach me, you can reach me as at Flynn on basically any of the CNCF Slacks, or email at flynn@buoyant.io, or just sing out of the workshops channel now. And that is it for this. Before we get into Q&A, if there is any, the next Service Mesh Academy is on August 15th. Metrics and dashboards and charts, oh my, where we get to talk about metrics and dashboards and charts. We would encourage you to check out Buoyant Enterprise for Linkerd. That's the thing I've been using on this one. And I believe that is it, unless anybody can think of anything else that we ought to cover.
Feel free to put your questions in the workshops channel on the Linkerd community Slack.
Anything come to your mind, Tom?
Well, I'm thinking, and I just threw this in the lower thirds, check out the Trouble with Topology-Aware Routing. It's 2-part. It was pretty cool. I worked with William on this and wrote some automation and made the things do the things. And he wrote the blog post, which is awesome. But it talks about, we get a lot of questions about topology-aware routing and why can't I just use that? And how does that compare to load balancing and Linkerd? And this is a great write-up of that. And, it's backed with some repositories that we've got out there too.
Yeah, it's pretty cool, actually. One of the things that we didn't get into in this demo, but I would kind of like to at some point a little later, is looking at having multiple clusters in multiple zones and arranging it so that you can keep traffic within one zone unless something goes down and then you route out to another zone. There's a lot of interesting stuff to be done there too.
Yeah, well, we've got a few minutes, right? I've got that up. Let me see here.
Yeah, go ahead. If you've got something you can toss up real quickly.
See if there's, hang on. It's my first time. That's the one. Okay. All right. So I'm in Buoyant Cloud over here, and I've got two different clusters. One called Orders, which has our Orders app on there, and it's just sending traffic to warehouses. Let me refresh this. Right now, I actually have Hazel disabled. So all of our Orders apps are talking cross-cluster in pod-to-pod multi-cluster with the warehouse cluster, which has the warehouse services running. And
in your case, you also have your clusters here each have 3 nodes, right?
3 nodes, 3 zones, right? So we've got an East zone, which is where the Orders East and the warehouse Boston live. West Zone, which is West in Oakland, and right here in the middle, we got Central Zone, which is Central in Chicago. But we've got the app configured just to talk to all the endpoints, right? So without any direction from the service mesh, they're just basically spreading these things. If we take a look at traffic distribution, it's like 1/3, 1/3, 1/3, right? Request rates. So it's all about 50 requests per second, theoretically. So I'm going to go and enable Hazel. I've got Bell 2.15.5, which just dropped this week. But right now I've got Hazel disabled. The external endpoint zone weights argument here for our destination controllers. What turns that on? I'm going to uncomment that. I'm going to apply it to both my clusters. And then we'll wait a minute. It takes a second for this stuff to kick in. I'm going to go over somewhere here. I have got the Grafana dashboard that I use for this little demonstration. We've got some different metrics here, right? But if you look at the top one, we call this kind of this is the big one right here. Right now, again,
I'm not seeing the Grafana dashboard.
Did it not? Oh, it did.
Is that a different window?
Hang on. Yeah, but I thought I exported the whole thing. Let me take a look at this. Replace screen sharing. I thought
modern technology is so
a whole window, right? And I switched the screen, and it doesn't want us to follow me. So, anyways, this is our Grafana dashboard that I use for this demo, right? And you can see again 2-to-1 traffic, and now Hazel's kicking in here. And this is one big mesh, right? Pod to pod multi-cluster. Everybody's got the same zone labels. So when we look at topology zones on each node, they've all identified as, 3 different zones, right? Central, east, and west. So those are the things you're going to have to make this work. But Hazel across, when you're talking pod to pod, proxy to proxy, doesn't differentiate in clusters. It's just like, hey, I want to keep this traffic in zone. These are our best endpoints based on how we've labeled it. And, then it picks the most choice endpoints out of those endpoints until we push the thing hard enough that, we can no longer satisfy with that set of endpoints. We start to add some less favorable endpoints, but still the goal is to keep everything online here. And then
Hazel's pretty cool.
If I hop back again, let's see if it'll follow. Probably not. I'm going to need to
Of course not. That would be too prerogative.
It lies when it says window. Oh, entire screen. Never mind. That's it's my take. Yeah, it's my take on it, right? Here we go. Oh, yeah, I'll have to set this later. So let's just export the window and call it a day. So let's go back to Buoyant Cloud.
Still not seeing it.
I'm going right now. Hang on. Here we go.
There we go.
Now, if I refresh this, and of course, it's going to take a second. Metrics are always a little behind because we ingest them, we process them, and everything. But we should,
especially because your cluster has to be feeding metrics periodically up to Buoyant Cloud, which then has to,
Yep. Yeah, it's collecting them locally, it's processing them, then it sends it up, then we process them, and then so we'll just have to give this a second, but reload here. Yeah, it just needs to catch up. You can see most of these are 50. It'll drop these off. Again, metrics trail, and so your past metrics are being calculated. But once we get, come on, it's gonna make me a liar. You could all these are pretty much 50 at this point. They should flip over here, and of course, not gonna work.
And of course they don't, because
of course it's a demo. But when we look at the Grafana dashboard now, of course, everybody's going to see that that's suspect, right? Yeah, it's just a matter of waiting.
Well, it is funny. I mean, I remember doing this for, I think it was the 2.15 features, maybe SMA, and I had exactly the same experience with, all right, come on, Buoyant Cloud, catch up. You can do it.
Yeah, everybody wants things in real time, and it's like, these things don't happen in real time. First of all, hey, you got to turn Hazel on. All the proxies have to say, hey, I'm doing this now, right? Then, and everything, it's out of a bucket of metrics, so you have to let the older metrics age out, and then the time to get in, process it on both sides, and all that good stuff. So,
yeah.
Yep. And like Flynn said, if you want to go up to Service Mesh Academy, we're going to have this as a recording so you can experience the embarrassment once more over and over again. And we do have a GitHub with all of these Service Mesh Academies. Great place to go ahead and go get the code, pick it over, and ask yourself,
Mock me for not writing enough comments.
yeah, why is this not refreshing? That's okay. So, anyways, at some point it will be pinned to zone 150, 150, and just these things move faster than the metrics.
One of the other really interesting things about Hazel when I try to work with it is that I always have to tune the load bands down because I tend to be doing stuff with faces. So you get to see, the different zones have different colors or something like that. And then, of course, everything tops out at about 8 requests per second, which from Hazel's point of view is nothing. Not much traffic at all,
Yep. All of mine have built-in custom load bands, right? Because again, I'm just turning a little bit of traffic here locally on my machine. And it's not, and even if you turn it up, you really can't push this stuff in real worlds, scenario. It works. It's amazing. Like we did a POC with a really big customer at load scale and turned it on. It was like 47% immediate reduction, and then it was like, okay, well, why are we not seeing more? And we found, pieces and parts that just needed to be duplicated in each zone and things like that. And I think we went from like 72% cross zone to 5% at the end when we had, like within an hour had that dialed in. And you could go and say, okay, what else is this necessary if you wanted to dig more into that. But it's very, very nice. But there's, it's not just about cross AZ and saving dollars. You can, people who have latency, aware apps, you can do that. If you're running in your own data center, put a top of rack switch in, label all of those nodes that are in that rack, one way, and then you could keep everything within the rack, but still have the advantage of, spreading it across racks or across data centers. So if you're doing on-prem, there's a lot of value in Hazel as well.
Yep. No, it's there's a lot of stuff like that where more control is better, right?
Yep.
But okay, I think that we can be done. I'm not seeing any other questions so far. Hope everybody enjoyed it. Thanks, Tom. Appreciate it. And I guess we'll see y'all in August.
Yep. Thanks for showing up. Enjoy your hot summer if that's where you're having right now, and be safe. We'll see you with the next one. What do we have again? We've got metrics and dashboards and charts. And this one is near and dear to my heart and a lot of customers and a lot of users because visualization and observability in a way that you can share it with people who don't live from a CLI, live to hack is huge.
Yeah. Also because metrics are kind of awful. So
yeah,
digging into making them less awful is a good thing, right?
They're like plutonium, right? They're extremely powerful, but very toxic if handled directly.
That's about right. Yeah. It's there's the pull quote for this SMA. Metrics are like plutonium.
That's right.
All right. Thanks, everybody.